To problem number 49 from homework 2.5 day 2. Here we're given a graph of a function, and we're asked to write the equation for the graph, and we're actually given the parent function. So for both of these, the parent function is the absolute value of x. So we need to think about what the parent function looks like and the transformations that we see. So the parent function, the absolute value of x, goes through 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. So I'm going to just put some points on the parent function on both of these graphs so that we can see the transformations that are going on. Okay, so what's happened here? This graph is reflected in the x-axis because it opens downward. But if it were solely reflected in the x-axis, I'll put those points in green, we'd have 0, 0, 1, negative 1, negative 1, negative 1, negative 2, negative 2, 2, negative 2. And that's not what we have. All right, we have the point 4, negative 2. So what's happened here, instead of going from 2, going to 2, negative 2, we're at 4, negative 2. So this graph actually has a horizontal stretch by 2. Right, because this point, instead of being at 2, negative 2, is at 4, negative 2. So we multiply x values by 2 when we transform the points. But within the equation, we're really going to multiply x by 1/2. So our new function has the equation y equals, to reflect in the x-axis, I put a negative outside the function, the absolute value of 1/2 x. Multiplying x by 1/2 within the equation will result in multiplying x values in the transformation by 2. Some of you may also see this as a vertical shrink, and it's a vertical shrink by a factor of 1/2. Because, for example, this point, which is at 2, negative 2 on the function just with the reflection, the function just with the reflection was at 2, negative 2, but our point is at 2, negative 1. So you could also see this as a vertical, so I'll put this as or, you can think of it as a vertical shrink by 1/2. If you think of it that way, you would write the equation as y equals negative 1/2 on the outside of the function, the absolute value of x. These are equivalent because I can pull that 1/2 constant outside of the absolute value. So either equation will be correct. And the second graph, we don't have a reflection in this case because our graph is still going upwards, but what's happened to our points? So normally we'd be at 0, 0, and we're at 0, negative 3. So we can look at the vertex to see about horizontal and vertical shifts. So this shows me that this graph has gone down 3 units. So there's a vertical shift down 3. And then what else has happened? Because if I just went down 3, I'd be at 0, negative 3. I'll put these points in green. I'd be at 1, negative 2. And I'd be at negative 1, negative 2. And I'd be at negative 2, negative 1. But instead of being at negative 2, negative 1, I'm at negative 2, 3. So normally I'd go left 2 and up 2. Here I'm going left 2 and up 1, 2, 3, 4, 5, 6. So this actually has a vertical stretch by 3. You see, that's normally I should go left 2 and up 2. Now I'm going left 2 and I'm going up 6 on my true function. So that means I have to stretch y values by 3. So to write this equation, to have the vertical stretch by 3, I'd put 3 outside the absolute value, and then minus 3 to do the shift down. And that's the equation.